firing of the engines on the Dragon spacecraft. At that point, it will separate into different pieces. The trunk portion, which has the solar arrays attached and is on the right side of the spacecraft on your screen right now, that'll detach and eventually burn up in the Earth's atmosphere, leaving the actual capsule, the Dragon itself, which is in the grasp of the robotic arm on the left side, top left of your screen, to eventually pass through the Earth's atmosphere, survive the fiery heat of reentry, and land in a parachute-assisted splashdown in the Pacific Ocean, where recovery experts from SpaceX out of California will be standing by to retrieve it from the ocean and bring it back into port. Again, this Dragon spacecraft is going to be packed with about 3,600 pounds of cargo set to make the trip home. When Dragon arrived about a month ago, it carried up about 5,700 pounds, and then gets packed with science experiments and other pieces of cargo throughout the time that it's actually attached to the International Space Station, and then bringing all of that stuff home. Dragon right now really the only major means of taking cargo from space, delivering it back to us back down here on planet Earth. Something really important for a lot of the research that's done on board. A lot of the cargo that Dragon delivers is something we'll call sortie science. So it's science experiments that spend only about 30 days on board the International Space Station. They have a clock kind of ticking as soon as they lift off from the Cape in Florida. The science is done on board the International Space Station by the crew, the Expedition 61 crew currently on board, and then packed back into Dragon for the return home. Dragon also returning a number of what we call cold samples. There are a lot of biological samples and other items collected from the astronauts and from various science experiments that have to be put on ice while they're on board just to maintain their integrity. And those get packed into Dragon in some powered cold lockers and then make the trip back home. You're getting a look now here inside the International Space Station Flight Control Room. The Orbit 1 team currently on console, and they're going to be overseeing Dragon's departure from the space station this morning. They are led today inside the room by Flight Director Rebecca Wingfield. She's right there in the center of your screen. Right to her right is Scott Zagady. He's serving as the Capcom for the team this morning, and you'll hear him talking to the crew on board, particularly with the current Expedition 61 commander, Luca Parmitano, from the Italian Space Agency. He's going to be overseeing the Dragon's departure. It will be ground-commanded release this morning. We've done it both ways throughout the past, either the crew on board commanding the arm to release Dragon or the ground here.
Station 2, go ahead.
Okay, Luca, we are go for Dragon configuration checks. You're going to perform step 2 in weather decibel 602.
Go for step 2.
And just now you heard the Capcom Scott Zagady talking to Luca Parmitano on board the station. Again, Parmitano going to mainly be in a monitoring mode for the release this morning. He's got a number of different steps that he's working through on his own checklist. A lot of it involves powering up the various hardware, both of the robotics workstation, which this is actually a view on board the International Space Station of that robotics workstation, and giving a lot of the different telemetry or the data coming from Dragon being beamed back to the station. The crew members, both for approach and departure for any visiting vehicle or any cargo vehicle, have the ability to step in and send commands to the spacecraft should it become necessary for any reason. The spacecraft performing a lot of their functions automatically, but the crew always in the loop just to act as that additional backup. So Luca Parmitano is going to be monitoring Dragon as it makes its departure from the station this morning, and he'll be at a command station where he's able to send things like abort commands or anything else to the Dragon spacecraft should it become necessary. But it should be a pretty slow and smooth ride away from the station this morning. You'll see Dragon get released from the end of the Canadarm2 robotic arm. Right now it's in the grasp of something called the Lee.
Luca on 2 for step 2. CCP command is on. I have VV mode free drift, primary sensor LiDAR 1, and the LED lights on the CCP correspond to the schematics.
Good info. Thanks, Luca.
And just there, Luca Parmitano, he's just, again, going through some startup procedures to get him ready in that monitoring mode. You heard him talk about a number of LEDs, so a number of lights on his command panel that he's confirming are on. Also confirming that they're getting good LiDAR. That's the laser and imaging data relay that the Dragon uses to primarily during that rendezvous portion to actually get range rate. So how quickly it's either approaching or in this case departing the International Space Station, also its relative range to and from the station itself. So the flight director here, Rebecca Wingfield, confirming that all of Luca's readouts were good and we're continuing to march along. The teams here in the room are primarily monitoring all the systems on the International Space Station, obviously. They're going to be working hand in hand with the team out in Hawthorne, California this morning at SpaceX Mission Control, where they've been overseeing and controlling the vehicle during its flight since it launched just about 32 days and change ago. And they're going to be controlling the vehicle as it flies away this morning out of 2 different checkpoints that we'll talk about in just a moment, and makes its way away from the International Space Station, again, ultimately setting up for that landing. We are targeting, again, the release coming in just about 10 minutes from now. A command will get sent to the robotic arm that will release a series of snares that are used to hold the spacecraft in place to that latching end effector. That's the lead, it's kind of the hand, if you will, of the robotic arm itself. That's the part right in the center of your screen, the very end of the arm, the white section that's attached to the grapple point on the Dragon spacecraft itself. The snares will open up. They're used in the initial capture and actually retract and grasp Dragon, so they'll open those up. Those will slowly release, and then once those are released, we'll see Dragon kind of floating there. They'll slowly back the arm away from the Dragon spacecraft, at which point it'll get a couple of feet away, and the Dragon will be able to make its departure burns. The very first burn will be very, very minor, only a quick 6-second burn, only changing Dragon's relative velocity by about 1/10 of a meter per second. That'll come about 2 minutes following that initial release. And then Dragon will begin to slowly drift away. Just about a minute later, it'll execute a second departure burn. This one about twice as powerful, going for 11 seconds and changing, again, that rate of, or Dragon's relative rate by about 0.2 meters per second, and that'll start to widen the gap between it and the International Space Station. Eventually, it'll move outside of what's known as the keep-out sphere. That's an imaginary sphere with a radius of 200 meters around the International Space Station, and then begin to, again, widen up that gap and then exit out something called the approach ellipsoid. That's this not to scale, but that approach ellipsoid, a 3-dimensional shape, 1 kilometer by 1 kilometer by 2 kilometers around the International Space Station. And these are just in place to really govern the different rules of vehicles approaching, or in this case, departing the International Space Station. We pay a lot more attention to these when they're on the way in, as vehicles have to demonstrate that thrusters are in good health, control computers are in good health, a number of different items before they ever move inside of these imaginary areas around the station. And these just help to protect the station. So while a vehicle's outside of that approach ellipsoid, they have to be in what's called a trajectory, an orbit around the Earth, that for at least 24 hours it's not going to move inside of that approach ellipsoid. So if they completely lost control of the spacecraft, we know for at least 1 day they wouldn't move inside of there. The keep-out sphere is basically the same rules. It's just a little more stringent, where before you're inside that keep-out sphere, you have to be able to prove that you'll stay outside of it for at least 4 orbits, which is about 6 hours, as it takes about 90 minutes for a spacecraft at orbital velocity at the height of the space station, about 90 minutes to do 1 full orbit of planet Earth. So as Dragon departs today, we'll keep an eye out for calls as it gets outside of that keep-out sphere and again outside of that approach ellipsoid. Once outside of that approach ellipsoid, you may hear the call that Dragon is 24 hours safe. So that again just means it's now in a trajectory that even if control was lost of the spacecraft for at least 24 hours, we know it's not going to move inside of that approach ellipsoid, that imaginary area around the International Space Station. So a lot of work being done in tandem between the flight controllers here in Houston and the flight controllers over in Hawthorne, just to make sure Dragon is on a safe flight away from the station this morning. Everything's looking good, though. Again, Dragon was unbolted and released from the Harmony module, where it's been docked for the last 30 days. That happening at 11:57 p.m. Central Time last night, 12:57 a.m. Eastern Time this morning. And in the hours since, the robotic flight controllers have maneuvered it down to where it now sits. We are just about 7 minutes away from the targeted release of Dragon. Again, it's all going to be commanded on the ground here, so somebody actually in mission control giving the command to the arm to release Dragon this morning. And that release targeted for about 4:04 a.m. Central Time, 5:04 a.m. Eastern. And with an on-time release, we'll see Dragon execute those burns, begin to depart the area around the station, and eventually set it up for the major burn, the deorbit burn, a little bit later this morning. On the latest timeline, we're showing about an 8:51 a.m. Central, 9:51 a.m. Eastern deorbit burn. That's a much more significant firing of those engines. Those will actually fire for just shy of 13 minutes, significantly slowing down the spacecraft and eventually allowing it to just drop out of orbit, lining its trajectory up with the Pacific Ocean, where Dragon will parachute down and splash down and get recovered by recovery teams from SpaceX, who will then haul the capsule back in to the port, and then all of the cargo on board will immediately begin the unloading process. Some of those items, especially what's known as the cold stowage, come out almost immediately and then start to get routed back. A lot of it here to Houston, where that gets parceled out to researchers all across the country and really all across the world, as a lot of different space agencies, even outside NASA, flying research on board these commercial vehicles and supporting the different research being done on board the International Space Station. Again, about 3,600 pounds of stuff, so experiments, materials, things like that. Also, some vehicle hardware going to be making the trip back down to Earth this morning. Just a couple of the highlights of some of the science on board, really focusing on kind of how spaceflight affects the different biological functions, and also taking a number of different looks at radiation. As a lot of the research we're doing on the station, it's really kind of that analog, that proving ground for what we're really looking forward to doing, which is the really long duration water eco, which are signal pathways that influence muscle degradation. So a number of these mice were actually genetically altered pre-flight to either enhance or inhibit that myostatin expression. And this is just looking at possible targets for preventing muscle and bone loss during spaceflight and making that recovery a lot easier once you're actually back down on Earth. Anyone who follows our crew members on board know that they're exercising for about 2 hours every day as the human body adapts to weightlessness. Things like bone and muscle mass can deteriorate pretty significantly without countermeasures. So they do a lot of resistive exercise, a lot of running on a treadmill that actually kind of harnesses them in and pulls them down towards it, just to make sure those hip flexors, those different bones, and those leg muscles get a workout, as otherwise when you're floating in microgravity, you're really not using them.
And Luca, back with you on 2. We are go for Dragon departure on time. Your go to step into steps 3 and 4 in 1.602.
Copy, we are go on time. Step 3 and 4 ready.
4 in 1.602.
And we're looking good for, again, an on-time departure. We're looking for that release to come in just under 2 minutes from now, about 1 minute 40 seconds away from the planned release of Dragon. Again, Luca Parmitano, the Expedition 61 commander, standing by. He's going to be monitoring Dragon's release this morning. So we'll stand by and keep an eye out on Dragon. Should be flying away shortly.
ISS thrusters are inhibited and ground in 1 is go for release on time, Luca.
Copy, go for release on time.
And at this point, they inhibit the thrusters over on the Russian segment of the station to ensure that we kind of are in a free drift. We're not doing anything to change the attitude. That way, both Dragon and the station will be in what's called a free drift, so they'll be able to release and then begin that flyaway, and that's just to make sure that the station isn't correcting itself at any point while it's kind of flying side by side with the Dragon spacecraft, and that just helps remove any chance of recontact or anything like that with the spacecraft. So again, we're going to see the release. Those snares will release Dragon away, and then they'll slowly back the arm away from the spacecraft, and we'll see Dragon start to float on its own, and then it'll almost immediately begin that first departure burn. Again, just a quick, about 6-second firing of its thrusters to begin moving it away from the space station.
Proceeding with release, Luca.
Copy.
And we're standing by for confirmation of release.
Release commanded.
And there you go, confirmation the release has been commanded. Standing by for release.
Snares are open. Begin monitoring for drift out.
Copy. I concur.
And there you can see Dragon drifting away, so we're going to call that release officially at 4:05 a.m. Central Time, 5:05 a.m. Eastern Time, with the station and Dragon flying 271 statute miles just to the southwest of Australia. Again, at 4:05 a.m. Central Time, 5:05 a.m. release. There you can see the space start to widen between Dragon and that robotic arm. The snares opened and the vehicle released. Now we're standing by for that first departure burn. Again, just a quick 6-second firing of thrusters on Dragon, moving it away from the station, changing its relative velocity by about 1/10 of a meter per second.
And Luca, we are proceeding to back away.
Copy, proceeding, we back away.
So that back away is going to be a command to the arm to start backing away from the Dragon spacecraft. So again, Dragon at this point still just floating on its own. The robotic arm itself now is going to retract away from Dragon back towards the International Space Station. And you can see things speeding up a little.
Back away in progress.
And that back away of the arm is in progress.
Copy, concur. Station Luca on 2, 1.5.
Copy 1.5.
The arm already about 3 meters away from Dragon, continuing to back away.
Station IC 4.5, ready to command the depart.
And we concur, Luca, your go.
Dragon depart commanded.
Copy.
And with that, the arm far enough away, Luca Parmitano issuing the depart command to Dragon.
Departure burn 1 is complete. Departure burn 2 is in approximately 1 minute. Monitor per step 5 in 1.602.
Copy, monitoring per step 5.
So at this point, the arm is finished backing away from the Dragon spacecraft. That first departure burn has been issued and is already complete. Again, that first departure burn, just about 6-second firing of Dragon's thrusters. At this point, Luca Parmitano continuing to monitor. He'll have a number of overlays, just making sure Dragon is flying away in the direction expected. Everything looking smooth so far with our operation today, this morning. Again, that release coming at 4:05 a.m. Central Time, 5:05 a.m. Eastern. At this point, the robotic arm is backed away. Dragon's first departure burn has been completed. We'll be looking for the second one, which will be about an 11-second firing of Dragon's thrusters coming up in the next 30 seconds. Meanwhile, Australia just coming into view beneath Dragon. This is both it and the station, about 268 statute miles in altitude. Just swinging up over the southern coast of Australia right now, about to make a pass over the heartland and then out over the northeastern part of the continent.
And Luca, departure burn 2.
Station on 2.
Go ahead, Luca.
Hey, we noticed that while the jets were firing for the departure burn 2, the blast from the engines was shaking quite vigorously the solar panels of Cygnus 12.
Okay, copy that, Luca. Thanks for that data point right there. I want to let you know, yes, burn 2 is complete. Burn 3 will be in approximately 7 minutes. So you can monitor per step 6 in 1.602. And we've also completed back away of the arm.
We back away complete and stepping into 6.
And so at this point, that second departure burn has been completed. The next one will come up in about 7 minutes from now. Dragon exiting the area away from the station. You did hear Luca Parmitano.
And Luca, back with you. ISS thrusters are enabled.
fuel.
And again, the ISS thrusters, so the station thrusters back, managing the attitude of the International Space Station. You did hear Luca Parmitano report that during that departure burn, they saw some movement in the solar rays of the Cygnus spacecraft. That one's still attached to the International Space Station, specifically some movement on its solar arrays. So teams taking that note, and they'll go off and see if there are any issues with that. They do a lot of analysis anytime vehicles are coming and going to and from the International Space Station for stuff like that. We'll call the plume of the actual burns when the engines fire. So they'll just go off and make sure there were no impacts to the Cygnus spacecraft. But Luca Parmitano did report down that he saw some movement in the solar rays during that departure burn. For now, though, everything's still looking good with Dragon's departure. 2 burns down. The next one will come up in a couple of minutes from now, about 5 minutes from now at this point. And that will just continue to carry it away from the International Space Station. At this point, we are already just about 100 meters away, and another 100 meters will be outside of what's known as the keep out sphere. Again, that's just this imaginary sphere. Actually getting some view from some of the cameras on Dragon itself as it flies away from the station now. But again, we're going to be coming up in that keep out sphere in about 100 meters. That's just one of 2 kind of imaginary checkpoints around the space station that help govern the different rules that have to be in place for vehicles coming to and from the space station. Once outside the keep out sphere, Dragon will be in what's known as a 4-orbit safe config. So if they were to lose control of the vehicle, we'll know it for at least 4 orbits. It won't come any closer to the International Space Station. And we'll continue to stick with it as long as we have views, or at a minimum until we're outside of the approach ellipsoid. It's a much larger kind of box around the space station, at which point Dragon will be what's called 24 hours safe. So even if the vehicle were to completely lose control, we know for at least 24 hours it won't move inside of that approach ellipsoid around the station. So continuing to fly away. That release again came just 10 minutes ago at 4:05 a.m. Central Time, 5:05 a.m. Eastern. All of this setting up for a splashdown a little bit later this morning. Right now still targeted at 10:41 a.m. Eastern, 9:41 a.m. Central. And still getting a view of Dragon flying away. If you're wondering why the screen looks a little pixelated, it's not uncommon for cameras in that radiation environment of space to actually take hits on their image sensor. So quite a number of the different cameras on board station have a lot of dead pixels actually, and will degrade over time much faster than they do back down here on planet Earth. We've actually had a number of different experiments looking at that phenomenon, including the very popular high-definition Earth viewing experiment, which unfortunately finally hit the end of its life just a couple of months back. That was just a number of commercial off-the-shelf cameras providing views of planet Earth, eventually overcome by the radiation and no longer functioning. For now, though, Dragon continuing to fly away. We should be coming up on that exit from the keep out sphere in about 35 meters from now, and then it'll continue to fly away, eventually getting outside of that keep out sphere. Dragon right now about 170 meters away from the International Space Station. And just now, Dragon completed a small maneuver. It's a 180-degree yaw maneuver, and that just sets it up for its third departure burn, which is now underway. Again, these departure burns just moving the vehicle away from the International Space Station. The third departure burn planned for about a 21-second firing of those engines.
I'm back with you on 2, Luca. Departure burn 3 is complete. Dragon is outside the keep-out sphere.
Copy. I can still track it for a little bit, I think, if you need me.
Yeah, Luca, we'd appreciate it if you continue to monitor that. We'll be able to cut you loose from that once it goes outside of the, the approach ellipsoid.
Absolutely. I have the whole morning available.
All right, and Dragon picking up speed now, a little more than 400 meters away. So it's outside of that keep-out sphere. You heard the Capcom Scott Skady give the call up, reporting the Dragon's outside of that sphere. Again, that's about a 200-meter radius sphere around the space station that's used as kind of a checkpoint as vehicles are approaching and departing, as is the case this morning. So the next call out we're going to be looking for is once Dragon's outside of what's known as the approach ellipsoid. And that again is a three-dimensional shape around the station. It's about 1 kilometer above and below and to the sides, and about 2 kilometers on either end of the station, so making kind of a pizza box shape around the station itself. That's used to help govern vehicles approaching and departing the space station. Once they're outside of that approach ellipsoid, they'll be configured to be in what's known as a 24-hour safe trajectory, meaning they won't pass inside of that ellipsoid for at least 24 hours, even with no additional actions of the spacecraft itself. So it is continuing to depart. This is actually a screen that Luca Parmitano is looking at on board the station, giving some different telemetry, some of the stuff to really keep an eye on. Those numbers in the bottom right corner, where you see the VV to ISS, the visiting vehicle to the International Space Station. Primary and secondary sensors, that top one, that primary is what we're looking at this morning. So as you can see, it's already 687 and climbing. That's just how far away from the station it is. Then on the right, that's the range and rate. So that's how many meters per second it's actually moving either to or from the station at this point. We're moving from. So picking up speed, it's a little over 3.1 meters per second moving away from the station. Once we see that number get to about 1,000, we'll be close, depending on exactly where its trajectory is, but then we'll get close to being outside of that approach ellipsoid. You'll hear that call, and Dragon will be well on its way home. Again, that release came this morning from the robotic arm at 4:05 a.m. Central Time, 5:05 a.m. Eastern. It was a ground-commanded release with the robotic arm ungrasping Dragon, while the station flew about 271 miles over water off to the southwest of Australia. Everything going smoothly so far today. This setting Dragon up for that eventual deorbit burn a little bit later this morning, targeted at 8:51 a.m. Central, 9:51 a.m. Eastern, which will, once completed successfully, splash Dragon down at about 9:41 a.m. Central, 10:41 a.m. Eastern Time in the Pacific Ocean, with about 3,600 pounds of cargo inside. And again, still standing by. We should be outside of that approach ellipsoid inside of a minute from now. And so Dragon now a little over a kilometer away from the station, standing by for confirmation that we're outside of the approach ellipsoid.
And Luca, back with you on 2. Good news. Dragon is outside the approach ellipsoid and on a safe 24-hour free drift trajectory. So with that, you're released from monitoring duties, and you are good to take care of your monitor deact and CCP deroute activities, and then have yourself a wonderful rest of your day.
Thank you very much, and it's been really an honor and incredibly involving to be here working with this Dragon, both for the capture and for the release. It's a nice conclusion to a very successful cycle, and I'd like to thank all the teams for the support, all the teams all around, from the launch all the way through the cargo operations and logistics support, all the way to today with the robotics, for everything that we were able to accomplish. It was really an honor working with you guys. Thank you very much. We know that together with Dragon, we are setting down not only valuable science, but also a little bit of our lives up here. So it's really been nice. Thank you so much.
All right, and thank you for those words, Luca. We appreciate it, and congratulations, and well done for you and the rest of the crew on all the work for this mission. Have a good evening.
And with that Dragon now well outside of that approach ellipsoid, you heard some final words from the Expedition 61 commander, Luca Parmitano. He and his entire crew on board working very diligently over the last 30 days while Dragon was attached to the International Space Station, getting a lot of that science done and packed back in, along with vehicle hardware and a number of other items comprising 3,600 pounds, making the trip home this morning. So with that, we had a release at 4:05 a.m. Central Time, 5:05 a.m. Eastern Time. Dragon departing the International Space Station, now outside of the approach ellipsoid and setting itself up for a deorbit burn a couple of hours from now. Again, that deorbit burn is targeted to come at about 8:51 a.m. Central Time, 9:51 a.m. Eastern, with a parachute assist splashdown in the Pacific following that, targeted at 9:41 a.m. Central, 10:51 a.m. Eastern. We'll be bringing you updates on the web, on the space station page, and various social media, just confirming Dragon splashdown later today once that occurs. So with that, though, that'll wrap our coverage for today. Thanks for waking up early and tuning in and saying farewell to this Dragon, making its third trip away from the International Space Station, this capsule in particular, having previously done this same maneuver back in June of 2017 and April of 2015. So with a smooth operation this morning, we'll look for a splashdown a little bit later today, get that science back on the ground, and close the final chapter on another successful resupply mission to the International Space Station. For now, though, we will go ahead and sign off. This is Mission Control Houston.